Alright, let's have a look at this couple of exercises, the integral of x sine x dx, and compare it with the integral of x sine of x squared. Alright, so what's the best choice for the first integral right here? Integral by parts, alright, by parts. And what about the second integral x sine of x squared? Just a regular u sub, right? Okay, let's have a look at both. Okay. So on the one hand, the integral of x sine x. So in this case, okay, let's go back to the LIATE L logarithms. Do we have any? No. I, inverse trigonometric functions. Do we have any? No. A, algebraic. Do we have any? Yes. So in this case, u equals to x, and then the dv part equals sine x dx. All right. So let's do the necessary operations here, where the du will be simply dx, but the integral of sine, be careful, what's the integral of sine? Negative cosine, right? Be careful, because I see this very often, integrating sine to get positive cosine, but recall that is the derivative of sine, the one that is positive cosine, but backwards, that's something else, right? That's the opposite sign. Okay, so we have everything u times v, x times negative cos, minus the integral of v, which is negative cos, dx. So that's going to be negative x cosine x plus the integral of cosine. Well, the integral of cosine in this case is positive sign. Alright, so the integrals and the derivative, they reverse the sign, right? The derivative of cosine is negative sign, but the integral of cosine is positive sign. Let's look at the other integral right here. Well, the integral of x sine x squared. Alright, and something I noticed a few of you did, to take u equals sine x squared du equals cosine x squared times 2x dx. And well, if we look at this, this is even more complicated than the original integral, right? But again, recall from what we did last time. For the u substitution, just keep in mind the pattern recognition. So look at what we have for the angle of the trigonometric function. So we have a squared whose derivative is 1 degree less, which we have over here. So let's use that. U equals x squared du equals to x dx, where x dx equals 1/2 du. Alright, so we have the integral of sine u times 1/2 du, which is 1/2 integral of sine u du, and the integral of sine cosine u plus c, don't forget the negative, and just back substitute for this one. 1/2 cosine of, in this case, x squared plus c. Alright, so that's the main difference between these two examples. So those two integrals that look very, very similar, but in this case, one tiny detail, one tiny number is enough to change the whole game. So in this case, we may need either an integration by parts or simply u substitution. And well, it's curious because the second integral looks more complex because of the power of x, but it turns out that it requires a simpler method to compute, as opposed to the one that apparently looks simpler, but it took us a differential, an integration by parts. All right. Okay, questions about this one? All right, so how about we take a 10-minute break